this is the start of the 1.2 set of notes. So hopefully you've got the 1.2 guided notes in front of you. This is going to take me quite a few videos to get through, because they're going to be short. I think it's just easier to do short clips. Alright, so what we're going to do in 2.1 is look at one variable data, two variable sets, alright, and applications of those. Understanding relations, which has to do with the two variable case. Domain and range in a relation. Graphing in the xy plane. Finding a midpoint. The distance between 2 points, and looking at circles. Alright, so that's what's in the 2.1 agenda. Alright, starting off, this first video is going to look at the one variable data set. So this is if I'm getting one set of information. So we're given either a table or a list of one set of data where all of the items in the table or all of the items in the list represent the same type of thing. Right? Either they represent the number of people at an event, the temperature on a given day, the score on a test, alright? So they're just a list of the same type of thing. To be assigned a variable name like an x value, or if it's a temperature or a time, a t value, alright, or something along those lines. It doesn't necessarily have to be x, but we do typically use x, but you could use t for time or something along those. You could be creative if you want to, or p for prices or something like that. So an example of a one variable case, suppose that my x values are the amount of money we spent on a game. Alright, so maybe some type of app where you spend money over maybe a 5-day period. Alright, so suppose one day you spent $2, another day you spent $3.50, another day you spent nothing, and maybe the fourth day you spent $5. Alright, so that's what we mean by a one variable set. Those are all dollar amounts, so they're the same type. Alright, I spent $2, $3.50, $0, $5 on this particular game over a day. Alright, so that's what we mean by a one variable data set. For one variable data sets, you can plot them on a single number line. You can find the mean value, the median value, and that's what we're going to look at for these. Alright, so first plotting them on our number line, the x-axis, which again, the x-axis is just a number line that represents our values. So my number line would be, again, the x values, which is the dollars spent. So starting 0, and then I have to go up to 5. So 1, 2, 3, 4, 5. Right? We just plot the points. These represent my x values, are all possible x values. These are the actual x values I did. So one of my x values was at 0, so there's 1 point at 0. Another x value was at 2, so there's my second point, which was at 2. Was at 3.5, 1, 2, 3, so 3.5 would be there. And then 5. So it's just that simple, just plotting points on my line. Alright? So there are my 3 points that represent my $3 amounts in my one variable set. Alright, well, we're going to look at an application type next of a one variable set where we're going to find the mean, median, and mode, and then we'll look at another one where we'll find mean, not mode, but mean and median, and then graph it. Alright, so suppose this is our data set. We want to find the average. Alright, so the average value is what we mean by, so mean. It's what are my values averaged to. So whenever you're talking about averages, and we do this for everything, right? We find the average amount we spent in a month, we find the average on our test scores, we'd add up all of our test scores, divide by however many tests we have, and that's our average. Right? And so that's what you do. When you find the mean, you add up all of the values in the data set, divide by however many were in my sum, right? The number of values. And so a simple example, which is the easiest way to understand mean, is kind of figuring out grades. Suppose Janet has 9 quiz scores. Right, each quiz was at 10 possible points. Her scores were the following. So there's her 9 scores. Alright, so those are her 9 quiz scores over the semester. What's her average, right? Her mean, which is her average quiz score. Well, the mean would be the sum of all of the values. So I take the 7 plus the 9 plus the 7 and another 7, the 10. So basically I add up all of those values, making sure I don't miss any. 2, 3, 4, 5, 6, 7, 8, 9. And then we divide by, there were nine scores that I added together, all right? So this would be the sum of all of our quiz scores. And then we divide by 9. So when you add all of those up, I believe it adds up to 72. All right, so 72 is the sum of all of her scores. There were 9 of them, and so the average would be taking the 72 divided by 9. And so her mean score is an 8. That's her average, right? That's her average. On average, she scored 8. Now, sometimes she scored more than that. Sometimes she scored less than that. But when we average them all out, her average score was an 8 out of 10. All right, so mean. So hopefully, again, mean's one of those things that we typically use a lot, especially with grades. All right, the next thing we're going to do with one variable sets is find the median value. All right, so for one variable data sets, the median value is the middle most value or the average of the two middle values. Right, you always have to order the sample to find the meaning. You have to put your numbers in order. Right? You either go from the lowest number to the highest number or vice versa. It doesn't matter as long as they're in order. Right, you go low to high or high to low. If it's an odd number of scores, so if you've got 9 or 7 scores, there should just be one middle score. If it's an even one, that's a little harder. What you do is you average the two middle scores. So you add up the two scores in the middle and divide by 2, and that's the average of the middle scores. All right, so looking at Janet, she's got 9, so she's going to be the odd case. All right, her mean scores, the first thing we have to do is order the space. So I've got to write them in order. I'm going to go low to high because that's just what I prefer. So I start with the lowest, which is 6. Next is 7, and I've got 3 of those, so I do all 3. And then she's got an 8, 3 9s, and again you list all 3 of them, and then the last score is a 10, and then I count to make sure I've got all 9. 1, 2, 3, 4, 5, 7, 8, 9. Alright, then it's got to be the middlemost score, and so what it does is you kind of look for the number in the middle. There are 4 scores here, there are 4 scores there, and so 8 is smack dab in the middle. And so that middle score is my median. Alright, so the median is 8, which again is just a coincidence in this case that it was mean and median aren't typically the same. Sometimes they are, sometimes they're not. It's just a coincidence in this example that they end up being the same. Alright, so just be aware of they're not always the same. Actually, a lot of times they're not. It just happens to be this data set that I chose. They turned out to be the same. Alright, so her median happened to be, her middle score happened to be the exact same as her average score. But they are two different things. Average is averaging out. Median is whatever number's in the middle. And so we're just going to do another example of that with another set. Alright, so another example, second example. Alright, suppose that the table given is the temperatures in degrees Fahrenheit that occurred in Minneapolis, Minnesota over 6 consecutive nights. So I'm assuming since there were such low temperatures, this must have been sometime in the winter. Alright, so one night it was negative 10 degrees, negative 4, positive 5, positive 8, 3, and 7. Alright, plot these temperatures on a number line, find the maximum, minimum temperatures, determine the mean of the 6 temperatures, and find the median of the 6 temperatures, and interpret your results. I'm going to remember that. I tend to forget the interpret the results thing, alright, which is actually important that you understand what it's telling you. Okay, so plotting it, so A, first my number line, which represents my temperature, so those are my x values, which are my temps. In degrees Fahrenheit, right? Those are the units on it. Actually, I might make that go over since I got to go down to negative 10. So there's my 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops, didn't quite make my number line big enough. 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, so negative 10 is my spot here. Negative 4, 1, 2, 3, 4. There's my negative 4. 5, 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5. So I need to go all the way out to 8. Oh shoot, didn't mean to do that. 6, 7, 8. 7. Oh, and I forgot 3. Make sure I got them all. 1, 2, 3, 4, 5, 6. Alright, so there are all my temperatures, alright, over the 6 consecutive days. Alright, and again, number lines, just plot the numbers on the number line. So just count how many spaces they are going. Either you go negative to the left, positive to the right. And then actually looking at the number line, it's easy to see what my max and min temperatures are. The maximum temp was the 8 degrees Fahrenheit, right? That's the biggest temp over the 6 days. The minimum temp was negative 10 degrees over the 6 days. Alright, was the negative, right? That's the minimum. Negative 10 was my minimum. Alright, determine the average, the mean, right? I want to find the mean temp. Alright, what was the average temperature over the 6 days? Well, it's the sum, and you do include the negative. A negative is part of sum. So I like to put my negatives in parentheses. So it's negative 10 plus a negative 4 plus 3, and then so on, 5, 7, and 8. And you do leave the negatives. The negatives are part of the sum. Alright, so you add all those up and divide by the 6, because that's how many numbers there are there, right? There are 6 temperatures. Alright, so up top, when I add all those up, right, it comes to 9, divide by 6, which is 1.5 degrees. So the average temperature over the 6 days, or the mean average temp, is 1.5 degrees Fahrenheit over those 6 days. All right, so that was that. Sometimes it was never 1.5. At least in the where we have them, it was higher than that or lower than that. But when we averaged it all out, it averages out to 1.5, or sorry, 1.5. All right, now the median, I believe, is the last answer. Median, and then interpret the results. So D is the median, which actually, they're already listed here, but I'm going to list them out again. Alright, so remember, when we do median, the first step is to list them in order, which again, I can just use my number line. Negative 10 was the lowest, then negative 4, positive 3, positive 5, positive 7, positive 8. And there were 6 temperatures. Alright, so this is the case where it's an even case, so there will be 2 middle values. Right, there were 2 here, 2 here. If I try to go all the way with 3, right, there's nothing in the middle. And that's actually what I want to find. I want to find the average here in the middle. And so what you do is, well, you take these 2 middle numbers. So this time we have 2 middle numbers. And you want to find their average. Alright, so in order to find the median, it's the average of the 2 middle numbers. So in this case, it's the average between the temperatures 3 and 5. So it's what's right in the middle of 3 and 5. Alright, so my median would be taking 3 plus 5 and dividing by 2. Alright, so we get 8 over 2. And so the middlemost number, alright, so the middlemost temp is 4 degrees Fahrenheit. And again, that would be the number that lands right in the middle of 3 and 5. So it should make sense that it's 4. Alright, 4 degrees temperature is the temperature in the middle of my set of numbers. Alright, smack dab in the middle of them. Alright, so however you want to interpret it is up to you, but it's the middlemost number. It's the number in the middle. And it's actually, this one is found by averaging the 2 middle temp. Alright, so I'm going to stop the video there. So this is the first video, which is over 1 variable sets. The next video is going to start with 2 variable sets. Alright, we'll pick that up in the next video.